Hello, ladies and gentlemen. Welcome to my lecture series, Introduction to Astronomy and Astrophysics. My name is Genis. I'm a physicist, an astrophysicist, and theoretical physicist. And to follow the lectures, you should have the knowledge of school physics and school mathematics. This lecture 1, the history of astronomy, part 1. I will give an overview what was discovered and developed through the centuries and millenniums. My old astrophysics professor said in the first lesson, astronomy is the oldest natural science because already the old peoples like the Sumerians and Egyptians had observed the sky and had a kind of astronomy. The oldest proof of a kind of astronomy in ancient times goes back to the Cro-Magnon people, the ancestors of the Homo sapiens. The Cro-Magnon people were observing the sky and they recognized that the seasons have something to do with the positions of sun and moon. Here we have some engravings in bones. These should show the moon phases. These are the oldest astronomical documents we know. The recordings are over 30,000 years old, from about 30,000 BC. We find paintings in the caves of Lascaux, France. They are interpreted as astronomical depictions. For example, they shall show the Pleiades. And a relatively new field of research is the so-called archaeoastronomy. Now we come to the first civilizations. We start with Babylonians. The Babylonians were the inhabitants of Mesopotamia. That is the area of the two rivers Euphrates and Tigris. And they had already been observing the night sky very intensively, and that in the 3rd millennium BC. Here we have the very first astronomer that is known by name. That is Nebuchadnezzar, and he lived about from 560 to 480 BC. Then after him, Kidino followed. He lived from about 400 to 330 BC. Then Berassus, 300 BC, around 300 BC. And Zeudenes, he lived about around 240 BC. In many clay tables where we find cuneiform, there are astronomical texts. The Assyrians obtained later many of those cuneiform writings. Here we have a picture. This is the Mulipin tablet. It contains many astronomical data. About 400 BC, the Babylonians could already determine the synodic period of the moon and the time of a revolution of the planets Venus and Mars, and that remarkably precisely. They used a calendar of 12 months with 30 days, and they added then a leap month, if necessary, to correct the calendar again. And that's why we have got today a year of 12 months that goes back to the old Babylonians. The Babylonians had a 24 hours day, the 12 was very important for them. And so they calculate, okay, 12 hours daytime, 12 hours nighttime. And so that's why we have a 24 hours day. And they knew the length of a year exactly with only a difference of 4 minutes. And also known for them was the Saros cycle. That is the periodic recurrence of solar eclipses. And they had names for the constellations of the zodiac. Zodiac, also originates from the Babylonians. Then we have the Egyptians. Since the 4th millennium BC, the Egyptians made astronomical observations. And the people on the Nile, they created a calendar with 365 days. And they made exact observations of the sun. Then about 2800 BC, the Egyptians had the very first sun calendar at all. Other people had rather a moon calendar at that time. And similar to the Babylonians, they had 12 months with 30 days, and they had 5 other days to have a year of 365 days. They determined the beginning of the year by the star Sirius. Sirius was very important in Egypt. They also remarked that they had to introduce a leap day every 4 years to make the correction of the calendar then. They too divided the zodiac into some sections. Now we have the Chinese, the old Chinese. Since the 3rd millennium BC, the Chinese made astronomical observations. Especially the court astronomers were doing that, astronomers of the emperor. They made many recordings. We know about recordings of eclipses of moon and sun, and they had also got a catalog of stars. Then in 2296 BC, they documented the appearance of a comet. Then there was a solar eclipse in 2137 BC. This is the earliest known recording of a solar eclipse. The astronomers Xi and He, they had not predicted the eclipse of the sun for that year, and so they were beheaded. That is according to a legend. Then 4th century BC, they had in their star catalog 809 entries, and this catalog dates back to the astronomer Xi Shen. Of course, the old Chinese had also got a calendar, and they divided the night sky in some constellations. And it is supposed that the old Chinese also knew the precision movement of our Earth. Then in 1054, there was the supernova event that has created here the Crab nebula. Yeah, very famous, the Crab Nebula. They called it guest star. Then here we have an old star map of the Chinese. Yeah, if we look onto the picture here below, this is obviously Big Dipper. And if this is Big Dipper, then we would have here Bootes and Leo. And then here there must be Little Dipper. And then this must then be Cassiopeia. Okay, it's not so important here. An old map of the Chinese. Then the Indians. Yeah, here we have a picture of the observatory Jantar Mantar in Jaipur with 14 buildings. And yeah, since 1500 BC, they were making recordings of the moon movement. And since about 1100 BC, they had a calendar. The zodiac was divided into 360 degrees and 12 constellations. Yeah, here the question is, was that development independent, or were there any contact to the region of Mesopotamia or the old Egyptians? That is discussed among historians or archaeologists. After 2 years of 30-60 days, it followed then a year with 378 days, to make the correction in the calendar. And that was during the reign of Prince Rama that some tables of the planet movements were made. Here we have a picture of the statue of the famous Indian astronomer Aryabhata. He lived from 476 to 550. With him there was an upswing of astronomy in India about 500 Anno Domini. And at that time they had built 5 observatories. Then we have the Melanesians. We are at about 1300 BC. The Melanesians are found in the northeast of Australia, and they especially had got a far developed navigation with the sun and the stars. And that was very important because we have there many islands, so they must reach other islands with their boats. They used, for example, Polaris and the Southern Cross, or horizon-near stars, like for example Altair in the Aquila constellation. The Maya, they were also engaged in astronomy, and we have in 3380 BC the earliest eclipse of the moon, which is handed down. If we calculate with modern computer programs backward, then it was obviously the eclipse of January the 17th in 3380 BC. But okay, that is not sure. There is a discussion among the scientists. It is sure that a calendar was introduced there earliest in 3373 BC. That means later than this moon eclipse had taken place. Then about 750 BC, the Maya discovered the 18.7 year cycle of the moon. Then 4th century BC, they already knew the synodic periods of the known planets, and they knew that eclipses are periodical, and they could calculate them in advance. They also knew, like other civilizations, that a year has got 365 days. But here they divided in 18 months of 20 days. That means, of course, they had to add a leap month of 5 days. Let me mention some other peoples. The knowledge of the Inca was similar. They had got a calendar of 12 months as well. And the Maya discovered the 18.7 year cycle of the moon. And they observed the supernova in 1054 too. Then the Aztecs used 2 calendars parallelly. They start from the same point every 52 years. One had got a cycle of 365 days, of course, and the other one a cycle of 260 days. It is also known that the North American Indians had a kind of astronomy. Here in the picture we see the famous Bighorn medicine wheel. It is situated in the Bighorn Mountains in Wyoming. And here we have Stonehenge from the 3rd millennium before Christ. It isn't really known who built Stonehenge. And there was found a sky disk in Nibra, or near Nibra, in Saxony-Anhalt, Germany. The age was dated to about 1600 BC. Now we come to the antiquity, and here we have especially the old Greeks. The old Greek philosophers. The Greeks were the first people who had a kind of cosmology, we can say. Other early cultures were only observing the sky, but they didn't make any models, or there is no proof, no evidence for other old cultures. The Greeks developed the first model of the universe. And we must say they had overtaken a part of their knowledge from the Babylonians. The first one we have here is Anaximander. He lived from about 610 to 546 BC. He supposed that everything is made of only one material, and he thought that the space outside Earth is filled with fire. It was about 600 BC, as Anaximander supposed that the Earth is floating freely in space and that things fall down to Earth from any direction. Then the next, that is Thales of Miletus. He lived from about 624 to 546 BC. And yeah, that was the time as Homer was writing his works, as Thales was the first one who tried to understand the universe by rational studies. Yeah, the others before, they made only speculations without any proof. Okay. And in about 585 BC, yeah, as Thales observed the sky, then it is supposed that he gave the constellation Ursa Major its name. And it is also supposed that he predicted a solar eclipse. The next one here in the chronology is Pythagoras of Samos. He lived from about 570 to 490 BC. Okay, firstly, the Greeks supposed that the Earth is a disk, and yeah, other early cultures made the same assumption. And he was now the first who thought that the Earth is a ball. Earth and the vault of heavens. And it was in about 500 BC that Pythagoras thought that we live in a heliocentric world. Accidentally, disadvantageously, later the picture with the Earth as the center of our solar system was generally accepted. Okay, but Pythagoras also supposed that the gleaming Venus is a planet like the Earth, and he gave that planet its name. Then we have Heraclitus of Samos. He lived about from 535 to 475 BC. And yeah, about 500 BC, he thought that the Earth is flat, but he developed the theory that the Earth is rotating around an own axis. He also thought that the seasons are caused by the sun. And he assumed that sun and moon are bowls in which a fire is burning. The next one is Anaxagoras. He lived about from 510 to 428 BC. And yeah, about 467 BC, he meant that the sun was a red glowing stone, and it should be bigger than the peninsula Peloponnese. And then he was accused for that. And he recognized that the moon does not produce its own light. The light from the moon that is reflected sunlight. And he had the right explanation for eclipses. Then we have Democritus of Abdera. He lived about from 460 to 370 BC. In about 400 BC, he meant that the Milky Way consists of many stars, like our sun, and he thought that the Earth had got an oval shape. And he recognized that the moon has got mountains and valleys, and again that the light from the moon is reflected light from the sun. Then we have Plato. He lived from about 427 to 347 BC. He especially is known for his writings about Atlantis. In about 380 BC, Plato thought that the Earth is at rest, and the sky with its objects is moving around it. Plato was a student of Socrates, and he thought that the stars are on the inner surface of a great sphere. He also supposed that other celestial bodies have got the shape of a ball, and that they are moving on perfect circular trajectories. And he said that moon, sun and the planets move around the Earth. Earth and sun especially put up the plane of the ecliptic. He knew that the ecliptic is tilted about 23 degrees to the celestial equator. Then we have Eudoxus of Cnidus, without a picture. He lived from about 408 to 355 BC. He was a student of Plato, and that was about 350 BC that he wanted to explain the movement of the planets by using some rotating spheres. For example, the moon then was embedded in 3 spheres, and the outermost of all spheres was carrying the stars, and between that outermost sphere and our Earth there should be more other spheres on which we find the planets then. He also found out that a solar year is 6 hours longer than 365 days. That was the most precise measurement of the length of a year at that time. And he drew the first usable star map. Then we have Aristotle. He lived from 384 to 322 BC. Aristotle had the idea of a ball for Earth and other planets, again like others before. He gave several reasons why that should be the case. There was a circular shadow of the Earth if we observe the eclipse of the moon. then we have a circular shadow on the moon. Yeah, another reason was if a ship is approaching a coast, then the summits of some mountains are seen first. He thought he could justify logically the assumption that the universe is finite. Yeah, if we assume that the universe is infinite, then a very, very far point would move around the Earth or Sun with the same angular velocity, and that would mean that the real velocity is indefinite, because the farther the star is away, the faster it must move. The next one, that is Aristarchus of Samos. He lived about from 310 to 230 BC. And about 280 BC, he was one of the first who was thinking about a heliocentric picture of our world. That means the sun is then in the center. And he also tried to determine some distances. But disadvantageously, the heliocentric model did not win out over the geocentric one. The main reason was that the daily sunrises and sunsets seemed to contradict to that model. He determined the size of Earth and Moon, but the result was not very exact. But the first good result of a measurement of the size of the Earth goes back to Eratosthenes of Cyrene. That's the next here. He lived from about 276 to 195 BC, and that was in about 240 BC that he measured the angles of incidence at different places on the Earth at the same time, at different days at the same daytime. That means he measured that in Alexandria and Syene. And due to the difference of the values of the angles and the distance between Alexandria and Syene was known, then he could calculate the circumference of the Earth quite exactly. And it was further suspected that other objects in the sky are ball-shaped bodies as well. Then we have Apollonius of Perga. He lived about from 240 to 190 BC. And in about 200 BC, he invented the epicycles. We should recognize here that there were some Greek scholars who had some other planetary models. There were Philolaus of Croton, 470 to 385 BC, and after him Heraclitus Ponticus from 390 to 310. And they compiled a model in which we have a central fire, and but the centrifuge, that's not the sun. The sun and the other celestial bodies should move around it. Then we have Hipparchus of Nicaea. He lived about from 190 to 120 BC. And it was about 134 BC. Later, especially Claudius Ptolemy, they developed the geocentric picture of our solar system, where we have the Earth in the center and the Sun and the other planets are moving around the Earth. Yeah, at that time not all planets were known. They knew the planets which we can see with our own eyes at night. So the last one we can see is Saturn. Then Uranus and Neptune were not known there in the Greek culture there. And yeah, they thought a spherical shell should enclose everything, and the stars should be on that sphere. Hipparchus is especially known for his compilation of a star catalogue of over 1,000 objects. He also discovered the precision movement of the Earth, the axis of the Earth, the epicycle theory, especially of Ptolemy then later, made it possible to make relatively good calculations of the trajectories of the planets. He wrote a very extensive work. There were several volumes. So the knowledge of the Greeks, astronomical knowledge, could be overtaken by the Arabs, and then from them it was brought to Europe. And then disadvantageously the geocentric model survived over the next centuries. Then as the next we have Claudius Ptolemy. He lived about from 90 to 168 Anno Domini now. Anno Domini. And about 140 AD, Ptolemy wrote the Almagest. That's the Arabian title. The original title, if we translate it into English, was Mathematical Treatise. The Arabs get the Almagest, and so the knowledge from the old Greeks came from Arabia to Europe, and the star catalogue of Hipparchus was included in the Almagest. There were 48 constellations. There is another important one of the ancient peoples, the Romans. Our calendar comes from the Romans, and firstly they used a moon calendar that based on the phases of the moon. It was about 700 BC as they divided the year into 12 months. 1 year is defined by the sun, the apparent movement of the sun around the Earth. At that time, they meant the sun is moving around the Earth. A revolution of the moon around the Earth takes 27 and a third days. sidereal, or 29.5 days synodic. So 1 year had only got 354 days if you use the synodic period. And so they had to add a leap month every year. But that method did not work very well. It led to great confusions, or some other corrections were necessary. Then we have Titus Lucretius Carus. He lived from about 99 to 55 BC. And so, in the first century before Christ, that Roman philosopher meant that the universe is indefinite. His reason was, if something had a border, then something must be beyond. In about 46 BC, the Roman calendar was replaced by the Julian one. And so the year had got 365 days. That means that only every 4 years a leap day is necessary to correct the added up inaccuracies. Then we come to the Middle Age. As the era of the great Greek philosophers passed, then there were several centuries without any progress in astronomy. The next we have to recognize are the Arabians. The heyday of the Greeks was over, and there were the Arabians which maintained the knowledge of astronomy. In 800 AD, the work of Ptolemy, Almagest, was translated. The Arabian name was Almagisti. The Arabians especially compiled new star catalogues. Then we have the Arabian Albertinius, or in the Arabian language Albertani. He lived from 858 to 929. He found out that the axis of the Earth is inclined to the ecliptic. That's what the old Greeks already knew. And he worked with the Almagest and improved the data within that work. He determined the length of a year very exactly, and he compiled new astronomical tables. The next one is Abd al-Rahman al-Sufi. He lived from 903 to 986. He also improved data and things of the Almagest. He made observation about the inclination of the ecliptic to the celestial equator, and he made a better determination of the length of a tropic year. Then in 964 he was the first who observed the Andromeda galaxy. At that time they didn't know that it is another galaxy, so he described it as a small cloud. In the same year, Al-Sufi published a book. The English title was The Book of Fixed Stars. Then we have Al-Biruni. He lived from 973 to 1050. He made many astronomical measurements some scholars met regularly at the court of Caliph Harun al-Rashid in Baghdad. There they had got some instruments to determine the positions of stars, for example. Then Prince Ulugh Beg, 1394 to 1449, that built a big observatory in Samarkand. There is a whole series of stars with strange name. The name came from the Arabian language. Here we have, for example, Algol, Subin el-Janubi, Betelgeuse, or Altair. And then Europe continues to make progress in astronomy. There was Alfonso X of Spain. He lived from 1221 to 1284. He, a Spanish king, ordered to work out new tables of the planet's movements in 1252. Because, meanwhile, it was known that the old ones of Ptolemy were too inaccurate. They are called the Alphonsine tables. Then we have the German astronomer Johannes Müller, or his other name Regiomontanus. He lived from 1436 to 1476. In 1472, he determined the trajectory of a comet for the first time. And 2 years later, in 1474, he published his planet tables in Nuremberg. He made many new measurements. Yeah, in that era, some doubts of the correctness of the geocentric picture of the world were rising gradually. For example, in the opinion of the Cardinal Nicholas of Cusa, 1401 to 1464, the Earth cannot be at rest, but he hadn't got any reasons or proofs for that. And he was believing in God and in mathematics. Furthermore, he thought, like others, that the universe was indefinite and that the Earth was not a preferred point of view in space. Now we have the modern times. From now on, there is some progress in the astronomical science again. Here a first milestone was Nicolaus Copernicus. He lived from 1473 to 1543. He recognized that the geocentric model of the world cannot be right. It was handed down from Ptolemy and Aristotle, and it is based on his own rather theoretical studies. One reason was that he found out that planets move the faster the nearer they are to the Sun. And further, the distances between the planets increase with a growing distance to the Sun. He knew the ancient scripts of Aristarchus, where we find a heliocentric model, and he published his works with the Sun as the center and a rotating Earth in 1540. And then shortly before he died in 1543, his main work appeared. And he died on May the 24th in 1543, at the age of 70. And that was a few hours after he had the first printed copy of his work in his hands. Unfortunately, Copernicus adhered to the circular orbits of the planets. He didn't introduce ellipses, and so he couldn't predict the positions of the planets correctly. Moreover, he had some problems to make theory and observations coincide. We must recognize here that there weren't any telescopes available at that time. Copernicus also assumed that the stars were very far away, so that it was not possible to measure the distance by using parallaxes. So very important in history is that Copernicus published his book with the Latin title De Revolutionibus Orbium Coelestium. That means in English, on the revolutions of the celestial spheres. And there he declared that the Earth is moving around the Sun. That was in 1543. Then the next one, that is Thomas Digges. He lived from 1546 to 1595. He took up the world model of Copernicus with the Sun in the center. He made the change with the stars on the outermost shell. He scattered them in the whole space. Then we have Giordano Bruno from 1548 to 1600. He was a monk in London, and he was a follower of Digges. He took up the idea of the cardinal of Cusa, and he was a proponent of an indefinite universe and the heliocentric model. He was burned then because of the discrepancies between him and the Christian doctrines. Then we have Tycho Brahe. He lived from 1546 to 1601. He made the most precise determination of the trajectories of the planets. That was in Denmark. He especially observed Mars. He thought, the Copernican world model was wrong. And he made the following conclusions. If the Earth is on an orbit around the Sun, then the stars must be seen at little different angles during a year. Today we know the stars are too far away, so it is not possible to measure the distance by using parallaxes. Only for near stars it is possible to make that. Brahe could not imagine that the stars are really so far away. Then in Prague he met Kepler at the court of the Emperor Rudolf. Then Kepler became his assistant in 1600. Brahe measured the position of 777 stars, 5 planets, and he observed the supernova in 1572. His observatory was in Uraniborg on the island Ven. Ven, earlier Danish, today it's a Swedish island. The next one are Joseph Scaliger, 1540 to 1609. He introduced the Julian date in 1581. Then we have Pope Gregory XIII, 1502 to 1585. He introduced the Gregorian calendar, that is the calendar we still use today. It was known that the period of a year in the Julian calendar was 365 days and 6 hours. Yeah, but the exact duration of a so-called tropical year is 365 days, 5 hours, 48 minutes and 46 seconds. That means it is shorter by 11 minutes and 14 seconds. And so that means that until 1582 an arrowhead summed up of 10 days. So yeah, the calendar was behind 1 day every 125 years. And the equinox in spring, that was originally on March the 21st. That is the date of the equinox like we have today. That is displaced to March the 11th. And so in 1582, under Pope Gregory XIII, and the recommendation of the astronomer Christoph Clavius, a new calendar was introduced. That is a calendar we still use today. In that calendar, we have to add a leap day every 4 years. But not in the multiples of 100. That means we do not add in 1900 a leap day. But in the multiples of 400, we do add a leap day. That means in the year 2000, there was a leap day. And with that rule, we need another correction after 3,300 years. Then we would have another error of 1 day. In 1604, there was a supernova explosion in our own galaxy in the constellation of Iolcos. And that could be seen by the naked eye. Then we have Hans Lippershey, or Lippers High, other possibility. He lived from 1570 to 1619. And in 1608 he invented the telescope. Today it is generally accepted that he is the inventor of the telescope, that German-Dutch spectacle maker. Now we come to discoveries after the invention of the telescope. The invention of the telescope was a milestone for astronomy because then many new discoveries were possible. Now we have here first Johannes Kepler. He lived from 1571 to 1630. After Prey had died, then Kepler overtook his position as the court astronomer. He thought that the heliocentric model is the right one. He made extensive observations of the planets and used the material of Prey that enables him to find his 3 laws of planets' movement. So in 1609 his first work was published, and there we find the statement that planets move on elliptical trajectories around the Sun. And the law of equal areas was also found there. Yeah, that goes back to the conservation law of angular momentum. Then it was possible to work with telescopes. And in his publication in 1619, there we find the third law of planet movement. Then in 1627, the so-called Rudolphine planet boards were published. They were the basis for many calculations of planet trajectories for a very long time. Kepler also supposed that there are two Mars moons, but he couldn't discover them. They were discovered far later in 1877. So in 1609, Kepler published his book Astronomia Nova. That means the new astronomy. And there he showed his 3 laws of motion of the planets. Then we come to Galileo Galilei. He lived from 1564 to 1642. The year of death, 1642, of Galilei was the year of birth of Newton. He was an adherent of the heliocentric model, and so he came into conflict with the Roman Church. And so he was brought to the Inquisition twice, and he had to renounce the Copernican model where the sun is in the center. And he was banished to his country house in 1632. He built a telescope by himself in 1609 and made some observations with it. Then he discovered 4 Jupiter moons and the sunspots and the Venus phases, and he spent much time observing the moon mountains. Many astronomical discoveries could be made then. Galilei tried to weight the air as the first one, and he also found out that all bodies fall with the same velocity down to the bottom. He recognized the inertia principle. He recognized the independence of the pendulum oscillation period of the swing. He observed, like others, the supernova in 1604. And because of the sunspots, he was able to see that the sun is rotating around an own axis. In 1609, Galilei built a telescope. In 1610, exactly on January the 7th, Galilei discovered 3 Jupiter moons, and on January the 13th, a 4th one. Then we have Simon Marius from 1573 to 1625. And here also in 1610, on January the 8th, Simon Marius, that was a German astronomer, discovered the Jupiter moons independently of Galilei. And he gave them the names Ganymede, Europa, Io, Callisto. Later they are called the Galilean moons of Jupiter. Also in 1610, Galilei was the first who observed the Venus phases. And in the same year, Galilei published his work Sidereus Nucleus, that means the sidereal messenger. The next, Christoph Scheiner, he lived from 1573 to 1650. In 1611 he observed the sunspots, and the next year, 1612, he published a work in Apelles Letters. Then 1613 Galilei wrote work about the sunspots. Galilei was probably the first who observed the rotation of the sun. In 1614, Marius published his work Mundus Jovialis, that means the world of Jupiter. And there he described Jupiter and his 4 moons. In 1627, the Rudolphinian tables appeared. Then 1630, China made a systematical analysis of the sunspots. So the next one we have Pierre Gassendi from 1592 to 1655. In 1631, he was the first who observed the transit of Mercury. Then we have Genis. He lived from 1611 to 1687. Hevelius is the founder of the topography of the moon. From 1642 to 1645, he made intensive observations of the moon, and he made some recordings of the surface. He also observed the sunspots, and he had discovered 4 comets. He supposed that comets move on parabolic trajectories around the sun. Yeah, that's not wrong. Then 1647, Hevelius published his work about his lunar observations. The title was Selenographia sive lunae descriptio, that means selenography or a description of the moon. Then the next, Giovanni Battista Riccioli from 1598 to 1671. In 1650, Riccioli discovered the first double star, and that was Mizar and Ursa Major. The next one, Christian Huygens. He lived from 1629 to 1695. Huygens constructed a better telescope, and so he was able to discover the ring of Saturn in 1655. It was only possible to resolve one ring. Today we know there is a whole system of rings at Saturn. And he discovered the Saturn moon Titan in 1656. He also made many contributions to classical mechanics and optics. He was the inventor of the pendulum clock in 1657. So we have here Huygens discovered the ring of Saturn in 1655. In 1656, Huygens discovered the Saturn moon Titan. And in 1662, Huygens introduced the so-called Huygenian eyepiece. That's a telescope with 2 lenses to reduce the effect of dispersion. Then we have James Gregory, 1638 to 1675. In 1663, Gregory developed the fundamental principle of a reflecting telescope. But only theoretically. A reflecting telescope has not such a great chromatic and spherical aberration like a lens telescope. But he didn't build such a telescope. Then Giovanni Domenico Cassini. He lived from 1625 to 1712. He discovered 4 more Saturn moons and the so-called Cassini division. He determined the distance from the Earth to Mars and the rotation time of Jupiter. In 1666, Cassini was obviously the first who saw the ice zone on the south pole of Mars, and he determined the rotation period of Mars. And now, Isaac Newton, he lived from 1642 to 1727. Yeah, he was born in the year in which Galilei died. He established the physical laws of motion and gravitation. Law of gravitation is named after him. And then it was possible to make calculations of the trajectories of the planets mathematically. So the trajectory of a celestial body could be predicted. In theoretical physics, there is a so-called Kepler problem. Here, the Kepler laws are derived out of the Newtonian law of motion. Yeah, we can say that Newton was the founder of celestial mechanics. In 1671, he built the first reflecting telescope. Here we have a picture. It's a replica of Newton's reflecting telescope from 1672. You can find that in the Science Museum, United Kingdom. Because of the physical laws of Newton, now some calculations were possible to determine the trajectories, the orbits of planets and other bodies. Some predictions were possible to find still undiscovered objects. So his famous book had the title Philosophiae Naturalis Principia Mathematica, means mathematical fundamentals of natural science. In 1668, Newton built the first reflecting telescope, and in 1671, Cassini discovered the Saturn moon Iapetus. 1672, Cassini discovered the Saturn moon Rhea. In the same year, he also determined the distance Earth-Mars. He used the parallax. In 1675, Cassini discovered the division of the Saturn rings. This division is called after him. Then we have Ole Römer from 1644 to 1710. In 1676, Römer was the first who made a usable measurement of the velocity of light. He used the eclipse of some Jupiter moons. In 1684, Cassini discovered two further Saturn moons. Those were Tethys and Dione. And in 1687, Newton published his book, Philosophiae Naturalis Principia Mathematica. Now, the next era, discoveries after the appearance of Newton's laws. Here in 1619, Cassini determined the rotation period of Jupiter. He recognized that there are different angular velocities in the atmosphere of Jupiter. The velocity depends on the latitude. Then we have Edmund Halley. He lived from 1656 to 1742. He calculated the orbit of the comet that was named after him in 1682. now some calculations were possible. Newton's laws and Kepler's laws are available. And he also asserted that the universe must be infinite because else it must collapse, because of the gravitational attraction of masses. In 1718, he discovered that the stars are not fixed. They change their positions to each other. He compared his own observations with the old recordings of the Greeks. Those were 1,500 years old. Especially he observed Arcturus, Aldebaran, and Sirius. Then in 1705, Halley published his work Synopsis of the Astronomy of Comets. There he described the trajectory of that comet that is named after him. In 1718, then Halley discovered the proper motion of stars. John Flamsteed, from 1646 to 1719, he compiled a star catalogue, the Catalogus Britannicus, that means the British catalogue. There we find 2,935 stars. The Atlas Coelestis is included there. He was the first who made a recording of Uranus, but it was only a light dot like other stars, so he interpreted it as a star. Then in 1725, Flamsteed's Historia Coelestis Britannica was published. It was prepared by his wife. Then the next we have James Bradley. He lived from 1692 to 1762. He was a discoverer of the aberration of light in 1728. Because of this effect, he could now determine the speed of light with a new method. That was in the same year. And he was the very first, obviously, who measured a relativistic effect in 1728 again. That was the relativistic contribution of the aberrant circular movement of stars at the celestial pole. We have then in 1728 discovery of the aberration of light, and 1728, same year, he discovered the nutation of the Earth. Then we have Thomas Wright from 1711 to 1786. First he thought that the stars are distributed randomly, but then later he recognized that there were some structures. He had the idea the stars are moving around the center of the Milky Way, on a ring or on a spherical shell. And he already assumed that the very far nebulous could be galaxies. In 1750, Wright published an original theory or new hypothesis of the universe. Then we have Nicholas Louis de Lacaille. He lived from 1713 to 1762. He named 14 of our today's 88 constellations. And from 1750 to 1754, Lacaille measured the position of about 10,000 stars, but only on the southern hemisphere. Then we have Immanuel Kant. He lived from 1724 to 1804. The nebula hypothesis goes back to him. That means that the different celestial bodies had condensed out of a giant gas cloud during their creation. And he took up Wright's thoughts and propagated a lenticular shape of our Milky Way. The Milky Way should be surrounded by other similar shaped objects. Out of this he developed a hierarchical model of the world. That means the moons are circling around the planets are moving around the sun, and the sun is circling around the center of the Milky Way together with other stars. So always the next bigger object together with similar objects is moving around a common center. Kant also supposed that those nebulas are very far away, so that the stars are not resolvable with the instruments, optical instruments at that time. Those nebulas should be an accumulation of many single stars. In 1755, Kant explained the creation of the solar system was a physical process. Okay, today we would ask, oh, what else? At that time, the church had some influence, and so, many believed in God, and there is the creation, another creation of our world in the Bible. Then we have Johann Heinrich Lambert from 1728 to 1777. He knew Kant, and today we see him as the founder of the hierarchical model of the world. That means that systems of lower order combine together to systems of higher order. And that without an end. In 1761, Lambert published his theory of the nebula hypothesis in Kosmologische Briefe über die Einrichtung des Weltbaues. He was a German scientist. That means cosmological letters about the establishment of the structure of the world. Then we have Joseph Louis de Lagrange. He lived from 1736 to 1813. In 1764, he studied the three-body problem by considering the system Earth, Sun and Moon. In 1766, Lagrange studied the movement of the Jupiter moons, and in 1772 Lagrange found the so-called Lagrange points within celestial mechanics. Then we have Charles Messier. He lived from 1730 to 1817. He compiled the first systematic directory of nebular objects in 1774. He wanted to make a distinction between the nebulas and comets. So he compiled the so-called Messier catalog. Today there are 110 galaxies, and within we find, for example, our neighbor galaxy Andromeda. It's the number 31 in the catalog. Messier discovered 13 comets, And in 1774, Monsieur published the first version of his catalogue. In this first edition, there were only 45 objects included. Then the last version, that was published in 1966, included 110 objects. In 1779, Monsieur discovered a cluster in the constellation Lyra, that is number 56 in the catalogue. M means Monsieur catalogue. Now I have been in my library and I have taken out a Monsieur catalogue. Now we look into this catalogue. Here we have M31, the Andromeda Galaxy, our neighbor galaxy in the local group. Here we have M74, another spiral galaxy. Here we see the Crab Nebula, that was a result of a supernova explosion in the 11th century. This M1. Then here we have the Sombrero Galaxy M104. And here we see M83, another spiral galaxy. Now we finished lecture 1, part 1. Next time we will continue with one of the most famous astronomers at all, William Herschel. So thank you for watching. See you next time. Goodbye.